Welcome back, my 7th grade advanced class. Let's go ahead and get this knocked out. I've got all the odd ones tonight. The instructions are the vertices of the figure given. We're going to rotate the figure as described. Find the coordinate of the image. We have number 1 here, and it says that A is 1 and 3, B is 2 and 5, C is 3 and 5, and D is 2 and 3. We're going to rotate this in 90 degrees counterclockwise, right, about the origin. So we're going counterclockwise. And remember, this rule means that we're going to take X and Y and swap them. And I believe Y is going to become, our new X is going to become negative. So the old Y will become negative X. And let's just double check that. Yes, we see right here with X and Y, the Y will come and become X, and it will become a negative. And the X value will become the new Y value. So A, which was 1 and 3, we'd swap this. This would be a negative 3 and 1, right? And then B prime would be negative 5 and 2. Then this C prime will become negative 5 and 3, and then negative 3 and 2. All right? Let's go ahead and look at, and that's without even having to do any graphing, as long as you can remember, going counterclockwise, we swap it, and X is going to become negative. And you might be saying, well, how do you know this is going to happen? You just got to remember, if you're going counterclockwise, everything is going to go ahead and swap over across the axis in which it's at. And that's going to be the y-axis, which is going to make everything turn to the opposite side, which would be the new negative x side of the axis. All right, let's look at factoring the expression using the greatest common factor. When I do this, I'm just going to get my pin here so I can show you all. We have 4n minus 32. It says factor the expression using the greatest common factor. We're trying to find out what values go into both of these. All right, there's no n in negative 32, so n is not one of the factors that I will go ahead and factor out. But 4 does go into 32. So I can say that 4 would be multiplied to n. And then let's see, a negative 8, because 8 times 4 is 32. Negative 8 times 4 will become 32. So the greatest common factor becomes 4. Let's see, let's go to number 5. Another way you could do this, or maybe a way that you've been taught before, is to take each one of these terms and break them down. Let's say I have 2y, and I decide I'm going to go ahead and make this, let's see, to break it down, I know this is 2 times y. And that's it. There's nothing else that breaks these down. Over here, I have negative 18. And to break negative 18 down, I realize that I'm going to have, I know 2 times 9 will do it, right? 2 times negative 9. And I know negative 9 can be, I can get rid of that, and that would be negative 3 times 3. So times negative 3 times 3. Now I find all the things that are in common. Well, I see over here only the 2 is in common from the top and the bottom. So the greatest common factor, says factor the expressions use the greatest common factor, is going to be 2, all right? And then inside of here, I see, oh boy, don't want that to happen. There we go. Over here, I see that I'm going to have, well, 2 times y will give me 2y. And 2 times, well, 3 times negative 3 is negative 9. So I put negative 9 here, because 2 times negative 9 will give me negative 18. Let's see how we did with those. I'm going to erase them one at a time. Remember, our answer to 3 was 4 is the greatest common factor, and we could factor out as 4 times n minus 8. And there it is, 4 times n minus 8. Then I can go ahead and take number 5. Remember, 2 is the greatest common factor. And we said we could factor this to 2. And y times y minus 9. Okay, so we see over here we got 2 and y minus 9. So yes, we did everything correctly there. And now we're ready to go on to number 7. This says the vertices of a pair of figures are given. They want us to determine whether the figures are identical. Identical. And identical means there's no change at all. They are totally congruent. So I got A, which is -2, -1. We got B, which is -2, -2. C, which is -1, 1. And D, which is -1, -2. Okay, so if I was to put this on a graph, and I'm just going to venture off here, and I'm going to do my work up here. Oh boy, that thing keeps on giving me a little issue, doesn't it? Okay, and if I'm going to do this, I realize I've got my graph here. I got -2 and 1. So this is -2 and -1. That's going to be about right here. We've got -2 and +2. So that's -2 here and then +2 up here. So we see these are going to be 1, 2, 3 away, right? So from here to here, we got 3. Next, we've got -1 and 1. So -1 and 1 is going to be right about here. And here we are with that weird little happening that when I write happens sometimes here. All right. And then we've got -1 and -2. So -1, right, and -2 is going to be down here. It kind of looks like when we look at it, it's kind of like a parallelogram, right? Wow, that thing is just going to keep on haunting me all night long, isn't it? All right. And we're just going to come straight here. Now, this one is saying -2 and 0. All right, so this time I've got -2, 1, 2, and 0, which will put it right here. Then we have -1 and 1. -1 and 1 will be -1 and then 1 down here. Okay. Then we've got 2 and 1. So I'm going to come over here and say 2 and then 1 over here. And then 1 and 0. So this would be 1 and 0, which would be right here. Oh, there we go again. All right, so when we connect these, remember I had -2 and 0, which was over here. I'm going to connect that with -1 and 1, and that was, let's see, -1 and 1 was over here, so I can connect these two. Oh, Lord. Just can't stop that from happening, can it? All right, so we're connecting these two. Then we've got 2 and 1. 2 and 1 was way over here. Then we got 2 and 0, right? Or 1 and 0, which would put this one right here. And I'm saying, are these identical? I can't say they're identical because this looks a lot smaller than this one here. So I'm going to go with no. It says quadrilateral A, B, C, D, and quadrilateral F, G, H, J have congruent sides and congruent angles. The figures are congruent. Okay, so when it asks, determine whether the figures are identical, I'm going to go with no, they're not identical, they're congruent. I'm going to erase all this mess here. All right, it says identify any congruent figures in the coordinate plane. Let's see here. Identify any congruent figures in the coordinate plane. Okay, what are congruent figures? They have the same shapes and stuff. Let's look at number 9, because that's the one I'm responsible for. I would say that I know this E, F, G, H is congruent to A, B, C, D. They are not congruent to, well, they have, let's see, this angle goes up 1 and over 2. This one does not go up 1 and over 2. So I'm going to say that it's just A, B, C, D, and E, F, G, H. So E, F, G, H, and A, B, C, D, right? A, B, C, D. These figures, okay, are congruent. Number 11 says the red figure is congruent to the blue figure. Describe a rigid motion between the figures. Okay, a rigid motion between the figures. Well, when I'm looking at it, I don't really see rotation because this is way farther than this, or closer than this is. I don't see reflection. If anything, I'm going to go with translation. We've translated this figure 1, 2, 3 down. Actually, 1, 2, 3, 4, 5 down, and 1, 2, 3, 4, 5 over. So 5 down and 5 over, 5 over and 5 down, however they want to say it. It says translate the blue figure 5 units to the right and 5 units down. Perfect. All right, let's go to number 13. The figures are congruent. So these are congruent figures. Name the corresponding angles and the corresponding sides. Okay. I would say B and C is corresponding with F and G. A and B is corresponding with E and F. D and C are corresponding with H and G. And A and D are corresponding with E and H. So the corresponding angles are angle A and angle E, angle B and angle F, angle C and angle G, angle D and angle H. All right. The corresponding sides, like I said, were A, B, E, F, B, C, F, G, C, D, G, H, lines A, D, E, H. All right. Number 15, you use a computer program to transform an emoji. How can you transform the emoji as shown? Well, if I was going to transform this, I would be rotating this image, because this is perfectly swerved like this one is. I'd be rotating it 90 degrees, right? Clockwise. Rotating the original figure 90 degrees clockwise. Perfect. I know that because this image, when I look at it, is the original, and it is turned 90 degrees. All right, number 17 says the houses are identical. Okay, I can go with that. What is the length of side LM? Well, L and M are going to be the same as D and C. So I would say 32 feet. It says which angle of JKLMN, that's JKLMN, which one of the angles corresponds with angle D? And that's going to be angle M. Then next it says side AB, right here, is congruent with side AE. In other words, they are the same length. Okay. What is the length of side AB? Well, we know if J and N are 20 feet, then AE is 20 feet, and that makes it congruent with AB. So AB is going to be 20 feet. All right. And what is the perimeter of ABCDE, the whole thing? Well, that makes this easy because I know if I add this up, remember, this is going to be 20 if this is 20. And if this is congruent to this, that means this is 20. That means I've got all of my side length right here to get the perimeter. 20 and 20, well, that's 2 times 20. Then we got 12 and 12, so that's plus 2 times 12. And then we're going to add that to 32. And here we go again. All right, so 2 times 20 is 40. 2 times 12, that's 24. We're going to add that to 32. Well, I know 40 plus 24 is going to be 64. And 64 plus 32, that's going to give us 96. So since this is feet, 96 feet. All right, let's see how we did. 20 feet, that's what we said angle AE was, and 96 feet for the whole perimeter. Awesome. I believe 18 is for you to do, which leaves nothing left for Frank. All right, Mr. Mendez is signing off. That should be a pretty quick homework to do. I'll see you in class for grading and talk to you soon.